Linear equation is an equation of a straight line. Okay, it contains two variables. And those are usually x and y. Okay. The standard form of a linear equation looks like this: ax plus by equals c, where a and b are just numbers called coefficients, and c is the constant, and this is a number that doesn't change. And the reason it doesn't change is because it's not attached to a variable. Okay. To identify a linear equation, okay, I'm going to put there up here, no variables are being multiplied together. No exponents on a variable. And no variables in denominators. Okay. So if we look at here, I have a y equals 4 minus 3x. There's no exponents, there's no variables in the denominator, and there's no variables being multiplied together. So this is linear. Okay, so this would give me a straight line. Here, this right there has x times y. So these are variables being multiplied together, so it's not linear. Okay, this is 1/3 y. The y is not in the denominator, so it's okay. And here I have y equals x squared minus 4. That x squared, because that x has an exponent on it, it's not linear. Okay. And if you had something like, say, 2 over x equals 3, this would also be not linear, because you can't have variables in the denominator. The x-intercept is the point where a graph crosses the x-axis. Okay, this is the x-axis, the horizontal one. Okay, and the y-intercept is the point where the graph crosses the y-axis. This is the y-axis. Okay, and they're always going to be in the form, the x-axis is always going to be some number and then a 0, because your x is going to be this number, and the y-axis is always going to be 0 and then some number. These are the forms of the intercepts, and that's because, if you remember, coordinate pairs go x, y. So to find the intercepts, if I look on the x-axis, I find where that point is that it crosses the axis. So I go 1, 2, 3, 4, 5, 6, 7, 8. So this is -8. So my x-intercept, is -8, 0. And then I look on my y-axis and I find where the graph crosses on the y-axis, and I go 1, 2, 3, 4, 5, 6, 7. So that number is 7. So my y-intercept would be 0, 7. You want to use intercepts when the coefficients divide evenly into the constant. Otherwise, you end up with intercepts that are fractions or decimals, and those aren't easy to graph. So what you do is you look at this and you say, okay, 2 and 4 both go into 16, right? This is a good time to use intercepts. Here I have -1 and 2 both go into 8. So this is also a good time to use intercepts. Okay? If these two numbers don't both go into this number, it wouldn't use intercepts. I'll use a different method because it's not going to go evenly, so you're not going to get, you'll get fractions or decimals, which are a pain to graph, right? So, in order to do this, essentially what you're going to do is to find the x-intercept, you plug in 0 for y, which just means that the y goes away. So really all you have to do is say, okay, I'm going to take the y away and I'm going to say 2x equals 16. So if 2 times x is 16, then x is 8. Okay, and then I go find 8, and I put a dot there. Okay. And then to do the y-intercept, what I'm really doing is I'm plugging in 0 for x, but that basically just makes the x part go away. So all you really have to do is say 4y equals 16. Like, you don't have to put this step up here. You just take away the x if you're trying to find the y-intercept. You take away the y when you're trying to find the x-intercept. If 4 times y is 16, then that makes y 4. So I go up to 4 on the y-axis and put a dot. And to graph my line, I just connect the dots and put arrows on both ends. And this is the graph. This line right here is the graph of this equation. We'll do the same thing again. I want to find my x-intercept, so I'm going to get rid of the y. So I have -x equals 8. Well, that means x equals -8. So I'm going to go over here. 2, 3, 4, 5, 6, 7, -8, and put a dot. And then for my y-intercept, I'm going to get rid of the x, so I have 2y equals 8. So if 2 times y equals 8, 8y equals 4. Put a dot on the 4. And then, connect your dots. Intercepts doesn't work out correctly. Like, 1 goes into 2, but a third, well, technically it does go into 2, but you'd have to be dividing by a fraction, and that's kind of annoying, right? The other way we can do this is we can make a table. Okay? So you make a t-chart for x and y values. I'm going to put in 0 for x first. And so what that means is I'm going to say y is equal to 1/3 times 0 plus 2. Well, that goes away. So that just means y equals 2. So when x is 0, y is 2. Then I'm going to plot that point. When x is 0, y is 2. Now, I could put 1 in for x, but then I end up with 1/3 plus 2. I don't want to do that. So I'm going to look for numbers that will cancel with 1/3. So multiples of 3. So if I put in 3, I get y equals 1/3 of 3 plus 2. 3 goes into 3 one time. So I get y equals 1 plus 2. Well, that's just 3. So then I can go over here and I go 1, 2, 3, 1, 2, 3. And usually you want to do 3 points when you're making a table, just to make sure. So I can go into the negative side, or I can continue to go positive. Which would you like to do? Positives or negatives? Positives? Okay, so the next number that divides by 3 is 6. So if I do y equals 1/3 of 6 plus 2, 3 goes into 6 2 times. So I get y equals 2 plus 2, which is 4. So I go over to 6, so that's 3, 4, 5, 6, and then I go up to 4. And now I have 3 points, and I can see that, yes, I'm making a straight line. So I just go and connect my dots. Of rate of change and slope, okay? Okay, rate of change is how much something changes. That doesn't even look like 2 words. Okay, rate of change is how much something changes over time, or it can be like another interval. Like here we have the number of computer games and the total cost. So it's not changing over time, it's changing over a number of computer games. But a rate of change is just, it's how much something is changing given certain circumstances. Okay, to find the rate of change. Okay, the rate of change formula, I'm going to call it ROC, rate of change. You take one of the y's and you subtract another y, and then you take a matching x and you subtract a matching x. So to find the rate of change on this computer game cost thing, I need to use 2 sets of points. So I can use the 6 and 234 and the 4 and 156, or I could use 4 and 156 and 2 and 78. I just need to pick 2 points. And what I'm going to do is I'm going to take the larger one minus the smaller one. If I do this one first and then this one second, I have to do this one first and then this one second. They have to go together, right? Okay. So if I do 234 minus 156, I end up with 78 over 2. And that will reduce to 39 over 1. And what does this tell me? This tells me one video game is $39. So that's the rate of change. For every one video game you add, you're adding another $39 to your total price. And this is where the variable rate of change is that the rate of change is not constant. It's different all the time. Okay? So it's a changing rate of change. Change. Okay. So we want to find the rate of change for 2000 to 2002, and then the rate of change for 2002 to 2004. Okay. So here's 2000 to 2002, and here's 2002 to 2004. This is X, this is Y. All right. So I'm going to do my Y's over my X's, and I'm going to do 2002 minus 2000. And I just have to write the 2 and the 0 because it's going to be the same difference. So 324 minus 317 is 7 over 2. And for the next one, I have 325 minus 324 over 4 minus 2, which gives me 1 over 2. Now this is the number of people who visited U.S. theme parks in recent years, and it was, I believe it was in the thousands. Might have been the millions. I'm not really sure about that. But what this is saying is that between 2000 and 2002, the number was increasing by like 7,000 every 2 years. But then it slowed down. From 2002 to 2004, it only increased by like 1,000 every 2 years. So that's what the rate of change is like the number of people slowed down. And how are the different rates of change shown on the graph? If we look at this, do you see how the lines have a different steepness? That tells us the different rates. The steeper the line, the higher the rate of change. The flatter the line, the lower the rate of change, right? So this was 7/2, but this was only 1/2. And you can see this is flatter than this. And this one's going to be even steeper than this one, right? If we figured that one out, it would be 10/2 or 5/1. But 10/2 is going to be steeper than 7/2. Does that make sense? So steeper the line, higher the rate of change. Constant rate of change is a straight line. Okay, so if we're going to determine if a function is linear, it needs to have a constant rate of change, which means the differences between all the y's has to be the same as the differences between all the x's have to be the same. All right, so what we can do is I'm going to rewrite these with a little bit more space. Okay. To go from a 1 to a 4, I add 3, right? To go from a 4 to a 7, I add 3. 7 to 10, I add 3. 10 to 13, I add 3. So these are all the same. To go from a -6 to a -8, I subtract 2. -8 to -10, subtract 2, subtract 2, subtract 2. These are all the same, and these are all the same, so this is linear. Okay. Over here, to go from a -3 to a -1, I add 2. To go from -1 to +1, I add 2. 1 to 3, add 2. 3 to 5, add 2. These are all the same. To go from a 10 to 12, I add 2. But to go from 12 to 16, I add 4. As soon as something didn't match, it's not linear. Slope. Slope is the same as rate of change, but it's just, rate of change is usually associated with actual physical things, right? You know, like how much gas costs over time. Like how much did the price of gas increase over time? Because we know it doesn't really go down much. Slope is rate of change, but it's just for a linear equation. So it's change in numbers. And it's the steepness of the line. Okay. A positive slope as you move, we always move the same way we would read a book. So we always move from left to right. So as you move from left to right, a positive slope is going to move up. Going from left to right. A negative slope is going to move down. A zero slope is going to be, I can't draw this very well. A zero slope is going to be completely flat. Okay, and an undefined slope is going to be completely straight up and down. So positive moves up, negative moves down, zero is completely flat, and undefined is straight up and down. Okay, first of all, M is the symbol for slope. I know you would think, well, it should be S because slope starts with S, but it's not S, it's M. And it's the same formula. It's y2 minus y1 over x2 minus x1, or people say change in y over change in x, and that's what this little triangle means. It means change. So what we do is it doesn't matter which point you pick to be 1 and which point you pick to be 2, but you do x1, y1, x2, y2. Or you could say this was x1 and y1 and this was x2 and y2. It doesn't really matter which is which. You'll get the same answer. Just so long as both of these are 1s or 2s and both of these are 1s or 2s. You can't have like x1, y2. Okay. We're almost at the end, I believe. So all you do is you plug in the numbers now. y2 I said was 5, y1 is 0, x2 is 1, x1 is negative 2, so it's 1 minus negative 2. Okay, so it's very important that you're subtracting whatever it is, and so if you're subtracting a negative, you're subtracting a negative. That's 5/3. So that's my slope, because this becomes 1 plus 2. So if I say x1, y1, x2, y2, I have negative 3 minus 4 over 2 minus negative 3. These are both negative, so that's negative 7. This is the same thing as 2 plus 3. So I have negative 7 over 5. Okay. Positive slope, right? So my line would go upward. Negative slope, so my line would be going downwards. I have x1, y1, x2, y2. So I have negative 1 minus negative 1 over 2 minus negative 3. 0 over 5. This is a 0 slope, because 0 divided by 5 is 0. So this is your flat line. Okay, so 0 up here, okay. This is fine. This is a flat line, 0 slope. And for my last one, I have negative 3 minus 4 over negative 2 minus negative 2, which gives me negative 7 divided by 0. You cannot divide by 0. So this slope is undefined, so this is one of those situations where you're going to get a straight up and down line. Is rise over run. So you're going to want to leave it into a fraction form, because what it means is your line is going up 5 and over 3. And here it's going down 7 and over 5. Like it tells you how far up or down it goes on the top, and then how far right or left it goes on the bottom. So you leave it in a fraction. Given points, but with a missing coordinate. Okay. So I have x1, y1, x2, y2. That's a terrible y. I'm not letting me get away with drawing y's like that. Okay. So I have x1, y1, x2, y2, and the slope is m. So I'm going to plug in what I have. So that's r minus 4 over negative 5 minus 1. Okay. Then I'm going to simplify it as much as I can. So negative 5 minus 1 is minus 6. Okay. I have a proportion. Remember we did these last chapter? So we're going to cross multiply to solve this. So what I end up with is 3 times r minus 4 is equal to negative 6. I'll draw like a little wavy. Okay, so I moved down. So 3 times r minus 4 is equal to negative 6. I'm going to distribute that 3. So I get 3r minus 12 is equal to negative 6, which I'm going to rewrite up here because I'm running out of room. Okay. Add 12 to both sides. And I get 3r is equal to 6. If 3 times r is equal to 6, I'm going to divide by 3 to get r equal to 2. So that's my missing coordinate, 2.